This is part 2 of that video, trisomy 21, the luckiest trisomy among the trisomies. Okay, so this is part 2 of that video, and I think you remember the clinical features of trisomy 21. They have upslanting eyes and small ears, protruding tongue, short neck and short height, and several other features, okay, including hypotone, single simian crease and short broad fingers, then wide sandal gap. Okay, at the end of previous video we were talking about the three mechanisms how the Down syndrome or trisomy 21 can happen. So we discussed about the non-disjunction, and we explain it can occur during the meiosis 1 or it can occur during the meiosis 2. If I summarize again, all cells, somatic cells, can undergo, not all, most cells can undergo mitosis, but during the gametogenesis, those undergo meiosis. Meiosis has two phases, that's meiosis 1 and the meiosis 2. So in the meiosis 1, during the prophase, metaphase, anaphase and telophase, there are several actions. So in the meiosis 1, the homologous chromosomes during the meiosis 1 metaphase, they come to the center of the cell. Homologous chromosome pairing is there, and then during the meiosis 1 anaphase, that homologous chromosome will get separated into two daughter cells. So they should be separated into two daughter cells, but if that is not happening, then one daughter cell not getting a home chromosome from that homologous chromosome pair, and one daughter cell will get two homologous pair instead of a one. So if it is happening in the 21st chromosome, that can lead to a gamete with two 21 chromosomes there. So if that gamete get fertilized, this can happen in the male or female. So if that fertilized, then the fetus can be a trisomy who is having 3 copies of 21st chromosome. So that is happening with the meiosis 1. And in the meiosis 2 also, I'll summarize again. In meiosis 2, what happened is, now already if the meiosis 1 has happened correct way, the daughter cells, there are two daughter cells with 23 chromosomes in each. Then that 23 chromosomes will show sister chromatid, and in the meiosis 2 there is sister chromatid separation. If that separation is not occurring, two sister chromatid will go to one daughter cell. So that also lead to formation of a gamete. It can be either male or female gamete with two copies of 21 chromosome. So if that is viable, if that gamete is viable and later it get fertilized, then the fetus will get 3 copies of 21 chromosome. So this non-disjunction, this is mainly due to a by chance. That means usually there is no genetic tendency to develop non-disjunction, and it said that non-disjunction is occur more and more frequently when the age of the parent is going high. So advanced maternal age specifically related with the non-disjunction. Okay, and now we are moving to the second category, that is Robertsonian translocation. For that, actually you need to know what are acrocentric chromosomes. Previous video I explained acrocentric, metacentric, submetacentric chromosomes. In there I told you chromosome 13, 14, 15, 21, 22 and Y, those are acrocentric chromosome. They have Q arm, but their P arm is very short, and it's mainly like satellite stroke, and the satellite is there. So they have very short P arm and long Q arm. And with the translocation, that part of the P arm, actually there is not much of P arm there, that from one acrocentric chromosome to other acrocentric chromosome, that P arm part will get fused together and the Q arm part will get fused together. So what happens is, even that P arm part get lost from the both acrocentric chromosome, not much problems occurring, and then they have fused Q arm together. So I'll show you image for that. Here you can see acrocentric chromosome with very short P arm, and P arm will combine with the break-in and rejoining, and the Q arm will combine. If this is occurring in a one person, since there is no total loss or gain of any chromosome material, as those parts are also still within the cell, there is no problem to that person. Problem arises with the Robustonian translocation is when they are forming gametes. So let's see. So here the 21 chromosome in this person had joined on the 14th chromosome, but this is a balanced carrier. There is no total loss or gain of any chromosome material. So problem arises when? So as I explained before, during the gametogenesis, okay, these homologous chromosomes, they get separated out, and only one chromosome will go to the one daughter cell. So that means one gamete cell. So what happens is, when they are separating out that 14th chromosome, so it can form some gamete with 14 chromosome, and some gamete of where 14 chromosome will contain 21 chromosome also. Okay, then in we know that all the 23 pairs of chromosomes with different combination pattern, 2 into 23 times combination pattern can happen during the gametogenesis, as I explained before. So some gametes will contain that combined 14-21 chromosome or from the 14 chromosome side, and when considering the 21st chromosome, so I think you can understand that if I tell the 13 chromosome, one gamete will contain first 30, and another gamete can contain second 30. So another likewise, one maternal side or either the paternal chromosome in a homologous pair, that they enter into the daughter cell. Okay, so some gamete can be formed with the 21 chromosome or with also with the 14 chromosome with that combined 21 chromosome. So that gamete have already 2 copies of the 21 chromosome within it. So if that get fertilized, there is a possibility of that fetus is having, if it is viable, having 3 copies of 21 chromosome in that cell, because when it fertilizes, the other cell also having a 21 chromosome, and this cell already having 2 copies of 21 chromosome, so they get triplet of 21 chromosome. The special thing is, if this is happening the Robertsonian translocation in the 21-14 or 21-13, likewise if it is happening, the chance of recurrence is somewhat less than when it happening between the 21-20. And I don't have a picture to show you the 21-21 translocation. In that case, you can imagine this other black color 21 is on top of this 21. Then when gametogenesis occurring, one gamete will contain 2 copies of the 21, and other gamete not contain any copy from the 21. So those 21 monosomy will not survive. They will die inside the utero. So the 21 trisomy can survive. Okay, so if the 21-21 translocation happen in that person, all the children born live will be affected with the Down syndrome, because 21 monosomy is not viable, they won't born alive. And 21 translocation, Robertsonian translocation, these people can be viable, but they will be affected with Down syndrome. That's the main target, that's the main important thing about doing karyotyping in Down syndrome people. Because if we detect during the karyotyping 21 translocation in genetic counseling, we will advise on alternative reproductive method, because the risk of having another child with Down syndrome in that case it's 100%. For 100% for sure, the next child will be affected with Down syndrome unless alternative reproductive method is used. Okay, that's the importance of doing karyotyping in Down syndrome. Then third type is mosaicism. How that is happening. Previous two mechanisms, that is non-disjunction or the Robertsonian translocation. Non-disjunction occur during the gametogenesis as a by chance problem, and Robertsonian translocation, it can be hereditary, even run in the families. And as I said, if it is 1421 or the 1321 or other Robertsonian translocation, the risk of recurrence is relatively, its risk of recurrence is there. Still we need to screen, but compared to that, if the Robertsonian translocation occur between the 21 the risk of recurrence is 100%, and those two types occur mainly before the fertilization. The problem occurs before the fertilization. Third type is mosaicism. Mosaicism occur problems occurring after the fertilization, that problems occurring during the mitosis. So as you know, during mitosis also there is a cell division, and there is no homologous chromosome pairing in the mitosis. There only sister chromatid division is there. If the sister chromatid not going to two separate daughter cell instead of going to one daughter cell, then that cell line can get trisomy in that cell line. Okay, and that is not seen in other cell line. So post fertilization abnormalities in the mitosis can lead to mosaicism. Okay, and that is present in the Down syndrome or trisomy 21 as well. Those are the main three mechanisms that can lead to trisomy 21: non-disjunction, Robertsonian translocation, and the mosaicism. Okay, and I think you learned something, and let's have another video, and thank you very much.